Hello, this is Scholar Strife doing some math today. In geometry, we'll be looking at using similar right triangles. So we have the altitude on hypotenuse theorem. So let's draw a right triangle. That's supposed to be a right angle. Let's try that again. Alright. And let's call this A, B, C. So what this theorem says is if the altitude is drawn from the right angle, so we have the right angle, and remember the altitude is like the height of the triangle, what happens is, so those are two right angles here, so BD is an altitude, BD is an altitude, and what it says is the altitude will divide the original right triangle into two smaller right triangles, and all three triangles, so the big one, triangle ABC, the triangle ADC, triangle ABC, triangle DBC, which is the right triangle, and triangle ADB, which would be the left triangle, they're all similar. That means we can use the stuff that we did last chapter, create a proportion, and figure out missing sides. So the altitude, so geometric mean altitude theorem, the altitude to the hypotenuse of a right triangle divides the hypotenuse into two smaller segments. The length of the altitude is the geometric mean of the lengths of the two smaller segments. So what they're saying here is AD in the above picture so they're saying that the altitude BD is the geometric mean between the two smaller segments that it got split into, AD and DC. And then using that same picture, the length of either leg of the original right triangle is the geometric mean of the length of the whole hypotenuse and the length of the smaller segment of the hypotenuse that is adjacent to that leg. So otherwise, AD over AB is equal to AB over AC. CD over CB equals CB over AC. So let's go ahead and try to do some examples. Okay, name the three similar triangles. Hint, sketch the three triangles with the same orientation of corresponding sides and angles. So how you put your similarity statement, how your letters go, does matter. So we have the original FGH. Oh, that doesn't look good. FGH. And then we have a right angle up top here. Okay. So what you want to do is sketch the other two triangles. So look at the left triangle and then compare. So from here to here, we need to figure out the two letters that we're going to use. So we know that the right angle is here. So the right angle on the left triangle is at J, so this will be J. Okay, and then looking at the left, comparing, we went from F to G. F to G is the small side, the small leg of the big triangle. So the small leg of the left triangle is FJ, and then the longer leg is G. So I have FGH is similar to FJG, which is similar to triangle. So let's look at the right triangle now. So I'm drawing it the same way. This is a right angle. The right angle is at J still. But this time we want the short leg. So this is G. So the short side is GJ. The longer side, longer leg, is JH. So this is similar to triangle GJH. Okay, let's try this again. Name 3 similar triangles in the diagram. So we have, if we draw it out like that, we have short, long leg, and then the hypotenuse. Okay, this is the original NLM. So triangle NLM is similar to triangle something, which is similar to triangle something. Okay, I'm going to look at the left small triangle. So the right angle is here. So the right angle is here. So we're at P. So P is in this corner. And then the short leg is NP, so N. And then hypotenuse with the long leg is L. Okay, so that is P and L. And that's similar to the right triangle. So the right triangle is, again, we start at P. This time the short leg is L. And then we have M. So PLM. All right, let's move on. The new stadium seating at Chiviak High has a drainage pipe BD to allow rainwater to drain. Find the length of BD. Answer in simplified radical form and in decimal form rounded to the nearest 10th. Alright, here we go. So it formed a right angle here. There's another right angle here. And that means that's the altitude, so we can actually use some of the formulas that we made. So they want to find the altitude. Okay. So if I want to find the altitude, I'm going to compare the left triangle to the right triangle. Okay. So let me draw that. So here is the left triangle. Actually, let me rearrange this. So we have short side, long side, hypotenuse. Okay, so the short side, from the looks of it, actually, so the long side, so the short side, we don't know because that whole side is 10 root 13. But we do know that the altitude is x. which is the long side, and then the hypotenuse for the left triangle is 20. And then let's draw the right triangle using same type. Okay, so we have short. So the long side, so this one happens to be the short side, and the hypotenuse is 30. Alright. So we can't compare these two triangles directly to give us an answer. So let's back up. So the altitude right here so that's one formula we can try using, but we don't know this whole piece or these pieces, so that doesn't work. So what we're missing here is we need to look at the big triangle. So the big triangle, so we have short, so if we're keeping the same, our short end, if we're keeping our short end on the bottom, that would be 20, and the long end is 30, and then we have a hypotenuse of 10 root 13. Okay, so now I can create a proportion in order to find x. So I can use either the two triangles on the right or the triangle on the left and the big triangle. I'm going to use these two triangles. So I'm going to create a proportion. I'm going to do short side. So x over 20 equals hypotenuse 30. So this is the big triangle, and then this is the right triangle. So I'm comparing the right triangle to the big triangle since they're all similar. I'm creating a proportion. So x over 20 represents the short sides of the two triangles, and then 30 over 10 root 13 represents the hypotenuses of the two triangles. So we're going to cross multiply. I'll get 10 root 13 times x equals 600. Okay, I'm going to divide by 10 first to get square root of 13 equals 60. And then divide by square root of 13. So we have 60 over the square root of 13. We don't like having square roots in the bottom, so we're going to multiply top and bottom by square root of 13. I'll get 60 root 13 over 13, which, punching in your calculator, 16.6 feet. Alright, checkpoint 2. Name the three similar triangles and find the value of x. Alright. Okay. So I'm going to start off with the big triangle. So the short end, then long end, then hypotenuse. So short leg, let's start off with G to D, and then to E. Okay, now let's compare the left triangle. Okay, the short side is GF, and then I went long, D. So triangle GFD. Okay, and then let's compare the right triangle. The short end is DF, long is E. Okay, so similar to DFE. Okay, I went short side to long side, back around. Okay, and then what else do they want? Find the value of x. Alright. So these are my three similar triangles. I want to find what x is, so df. So let's find two that share So I'm going to compare GD, which is the short side, over GE, equals DF over DE. So 6 over 10 equals x over 8. Cross multiply, you'll get 48 equals 10x. So I'll get x equals 4.8. Example 3, find the value of y. So if that checkpoint, last checkpoint, seemed really confusing, let's try it a different way. So what I'm going to do is always draw your three triangles. It helps a lot. So I'll first start off with the big triangle. So I'm just recopying just the big triangle. So I have LKJ, and this is Y. This is blank, so we're going to leave it blank. And this is 24. Okay. So, and you also want to make note that this is the short side, short leg, long leg, and the hypotenuse. Okay. When you draw your other triangles, you want to keep it in the same orientation. So that means I have a long leg, a short leg, and a hypotenuse. Okay. So this one is going to be, let's say, the left triangle. Okay. So that would be M here. So this is the right angle. The long leg of the left triangle is L. So this would be 24 minus 9, which is 15. Okay, and then lastly, the short leg, we don't know. And then lastly, let's look at the right triangle. So again, long leg, short leg. Maybe I should use colors. So red here. So I have a long leg, a short leg, and a hypotenuse. Okay. So the short leg of the red triangle is 9. Our hypotenuse of the red triangle is y. And then we have nothing for our long leg. Okay. So now we're going to look at our three triangles and see if we can find a way where we can solve for y. Because we want to create a proportion. So the big one has the short leg and the hypotenuse. One of these other triangles also has a short leg and a hypotenuse. And that happens to be the black and the red. So I'm going to do short leg over short leg. So short leg over short leg equals hypotenuse over hypotenuse. And using colors, short leg of the big triangle, short leg of the red triangle equals hypotenuse of the big triangle over hypotenuse of the red triangle. So short leg of the big is y, over short leg of the red, which is 9, equals hypotenuse of the big, which is 24, over y. So we're going to get y squared when we cross multiply equals 9 times 24, which is 216. Take the square root, and we'll get y equals 216 breaks down into 36 and 6. So that's 6 root 6. Alright, checkpoint 3. So let's create 3 different triangles. So let's make the original black here. We have a short leg, long leg, hypotenuse. Short leg is y. We don't know the long. And then the hypotenuse is 15. Okay, let me use a different color here. Let's do the blue triangle. So again, short, long, hypotenuse. Okay, the hypotenuse of the blue triangle is y this time. Short leg is 4. And we still don't know the long leg. So right here, I don't need to do the third triangle because these both have the short leg and the hypotenuse. So we can set a proportion. Okay. So I'm going to do short leg of the left triangle over short leg of the right equals hypotenuse of the left over hypotenuse of the right. So y squared equals 60. And the square root of 60 is... Well, 60 can be broken down into 15 and 4. Square root of 4 is 2. And we're left with 15 inside. Alright, you are a truck driver, and you need to find the height of an overpass above the road to make sure that your truck is not too tall to drive under it. You measure your distance perpendicular from the wall of the overpass, 6.9 feet, at the height of 5 feet above the ground. If your truck is 13 feet 8 inches tall, can you drive under the overpass? Okay. 13 feet 8 inches tall. So let's go ahead and convert this. Okay, let's do this. So we're trying to find out 5 plus x. Okay, so I'm going to draw my 3 triangles again. So let's start off with the big triangle. I have a long side, short side, hypotenuse. So this is the big triangle here. This is x plus 5. This is the long side, which we don't know, and then the short side, we don't know. Okay, now let's look at... Oh wait, we do know the nope, don't. So then let's compare the red triangle here. So long side, short, hypotenuse. Okay, the hypotenuse of the red triangle we don't know, but we do know that the short end is 5. Okay, and that's all we have for that. Oh, nope, and then the long side is 6.9. Okay, and then the blue triangle. So long leg, short leg, hypotenuse. The short leg of the blue triangle is 6.9. We don't know the hypotenuse, but we do know that the height is x here. So we're going to be using proportion using the red and blue triangle. So long leg of the red triangle over long leg of the blue triangle, is that equal, or set that equal to short leg of the red triangle over short leg of the blue triangle. So 5x equals 6.9 squared, which is 47.61. Divide that by 5, and you'll get x equals 9.522 feet. Okay, add that to 5. So the overpass height, or the overpass height, is 14.522 feet. If your truck is 13 feet 8 inches tall, that means it'll fit. It'll fit under the overpass. This probably was a little confusing, but hopefully by the end you understand it. Have a good day.